How vast is the IPv6 address space? Imagine a world where every grain of sand on Earth could be an individual address. Now picture that number multiplied by trillions. That's how big the IPv6 address space really is. IPv6 addresses are made up of 128 bits, which means they can create a total of 2 to the power of 128 different addresses. That number is approximately 340 undecillion addresses. To put that into perspective, it's about 340 trillion unique IP addresses. Compared to IPv4, which only has 2 to the power of 32 addresses or about 4.3 billion, IPv6 is unimaginably larger. This vast space was designed to handle the explosion of internet-connected devices like smartphones, smart appliances, and Internet of Things gadgets. IPv6 addresses are written in hexadecimal, which is a base 16 system, and divided into 8 groups. Each group contains 4 hexadecimal digits. This makes the addresses longer and more complex than the 32-bit IPv4 addresses, but it also makes them more flexible and easier to manage at large scales. If you think about distributing these addresses evenly among the current global population of around 8 billion people, each person could theoretically get about 40 undecillion addresses. That's enough for every person to have their own unique address for every device they own, now and in the future. Large blocks of IPv6 addresses are assigned to organizations and Internet service providers. For example, a typical allocation might be a 32 prefix, which contains about 4.2 billion 60 for subnets. Each of those subnets can hold roughly 18 quintillion addresses. That means even the smallest subnet can support an enormous number of devices. This huge address space also means network management is simpler. It reduces the need for techniques like network address translation, which were used in IPv4 to conserve addresses. With IPv6, every device can have its own unique global address, making direct connections easier and more efficient. In practical terms, this vast space supports the ongoing growth of the Internet. It allows for the expansion of data centers, fiber optic networks, and undersea cables without running out of addresses. It's like having an endless supply of addresses that can grow with the Internet's needs. So, the IPv6 address space isn't just big, it's practically limitless for the foreseeable future. It's built to support the ever-increasing number of devices and the complex web of connections that make up the modern Internet.